Okay, well here we are, and I want to welcome everybody to Closer Encounters Live. This is something new. I've never done this before, so we're going to see what happens here today. It's a beautiful day outside here in Minnesota. Of course, it's Memorial Day weekend, so I do apologize for any of the background noise you may hear with vehicles running up and down the road. But hopefully, hopefully we can get through this anyway. Okay, before we really get started on what we're going to do today, of course, as the post, I'm going to be talking about black holes and show you a little experiment I got set up here, and hopefully we can explain some of this. And if anybody else has any input or whatever, just throw it there on the comments, and we'll see what we can do here. So anyway, before we get started, I brought out the computer, and we'll see here. I went to Google, and we went to the NASA. Page here on what exactly a black hole is. So let me see if I can flip this phone real quick, and let me try that. Okay, here we go. I don't know if you're going to be able to see this because it is kind of bright out here. I'm sorry, I apologize. Like I said, it is my first time, and maybe I turn it this way, huh? If you guys can read it. If not, I'm going to read it, and if you can follow along, that's fine. But the question is what is a black hole? And of course it shows some artist drawings of a black hole, and it formed when a large star caved in. The black hole pulls matter from blue stars inside of it, beside it. You can see there up here at the top, you can see this blue star, and it's pulling all this matter in, making a ring here. This is just an artist rendition. It's not an actual picture. Okay, let's scroll down a little bit more here. Another picture somebody made. Pretty awesome stuff here. Good looking pictures. Okay, Sagittarius A, which is kind of ironic because I am a Sagittarius. It is a black hole in the center of the Milky Way galaxy, so that's what they call the black hole that's in the center. As you can see here, a little close-up video, it shows this is a black hole here. This is a Milky Way, and this would be the black hole, and they call that Sagittarius A. So that's pretty awesome. I like that. Okay. Now this is kind of it's kind of simplistic. As you say, this article is part of the NASA knows kindergarten, grades kindergarten through 4. So, if it seems simple to you, that's because it is. This is designed for kids in school and whatever, but it gives you a basic idea of what a black hole is anyway. A black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. And it goes on to say, because no light can get out, people can't see black holes. They are invisible. Space telescopes with special tools can help find black holes. The special tools can see how stars that are very close to black holes act differently than other stars. And it asks a question, how big are black holes? Well, black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. Now, any of you know how big an atom is? You can't see it. It's invisible. It's minute. These black holes are very tiny, but have the mass of large mountains. Mass in the amount of matter or stuff in an object. Another kind of black hole is called stellar. its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy. Earth's galaxy is called the Milky Way. That's our galaxy. That's the one that we live in. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole, and it's in its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns. You read that? 4 million suns, and would fit inside a very large ball that could hold a few million Earths. Then it asks, how are they formed? And it says scientists think that smallest black holes formed when the universe began. In other words, as soon as the Milky Way appeared, so did black holes. Stellar black holes are made when the center of a very big star falls in upon itself or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. Scientists think that supermassive black holes were made at the same time as the galaxy that they are in. So it's pretty cool. If black holes are black, how do scientists know they are there? A black hole cannot be seen because strong gravity pulls all of the light into the middle of the black hole. But scientists can see how the strong gravity affects the stars and gas around the black hole. Scientists can study stars to find out if they are flying around or orbiting a black hole. When a black hole and a star are close together, high energy light is made. This kind of light cannot be seen with human eyes. Scientists use satellites and telescopes in space to see the high energy light. That's pretty awesome. And then, of course, there's another question here. And it says, could a black hole destroy Earth? All right. Black holes do not go around in space eating stars, moons, and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for the Earth to do that. Even if a black hole, the same mass as the Sun, were to take the place of the Sun, Earth would still not fall in. The black hole would have the same gravity as the Sun. Earth and other planets would orbit the black hole as they orbit the Sun now. The Sun will never turn into a black hole. The Sun is not a big enough star to make a black hole. And I don't know, I have to kind of disagree with that, but we'll talk about that here in a second. And it says here, NASA is using satellites and telescopes that are traveling in space to learn more about black holes. These spacecraft help scientists answer questions about the universe. Okay, so that gives you a roundabout description and stuff on black holes. Let me put this down here for a second, and we'll switch the camera back around. Okay, here we go. Alrighty, so anyway, so what they said was that the black holes and that, now in one paragraph it says that they are as small as atoms, which is, you can't even see an atom. It's just, there. And then, of course, it said that they can be as big as 1 trillion suns. Well, then in another paragraph it also states that the Sun couldn't make a black hole because it's not big enough. Now, I don't know how big a sun has to be to make one, but it does say that in order to make a black hole, it's just a star that implodes on itself and, becomes a supernova or whatever. So I don't get their logistics here, but, it is what it is. So maybe I'm missing the point somewhere or something. Who knows? Could be. But anyway, so what I did was I set up this experiment and kind of a visual aid. And I'll explain to you what I'm using here. What this is, and I'll show it to you here real quick. I'm going to flip the phone again. Okay, what this is what we call a blue bowl, and it is used in gold mining, prospecting, which I've done for many, many years. A lot of you that know me know that, you know, this is what I do sometimes on the side. But this particular apparatus is used for cleanup purposes for my fine material, and you know, I put my cons in there, and of course it cleans out the black sands, and hopefully any heavies that are left is gold. But today we're not going to search for gold. Today we are showing you what a black hole looks like and what it actually does. So anyway, inside of this blue bowl, if you notice, I'm going to try to block the sun out here. If you notice, there's a hole here in the center, and that's going to represent our actual black hole. And around the hole, as you can see, there's water, and that is going to represent our space. Okay, so that is what our space is. Right now the space is with nothing in it. Okay, just water. That's all there is. And what I'm going to do is I'm going to turn on the hose here, and we're going to get our space to do a little spin. So let me turn this on just a wee bit here and get this thing moving. There we go. Now, as you can see, we got space there, the water, which is going to be our space. Twirl it around there. And we're going to give it a minute here, and then we're going to add a galaxy. We're going to make a galaxy. I'm going to show you how we're going to do this here. But look at that. See that little piece here floating around? And you see it's going into the black hole, and oop, there it goes. It's gone. Okay. I'm going to turn this up just a little bit more. A little more action on our space here. I don't want to go too fast with it, but get this running here a little bit, and we'll show you how this is going to work. Okay. Now what I did was I went and sifted out some sand out of a sandbag, and I put it here in this pan, as you can see. And this here is going to represent our galaxy. This is what I'm going to use. And all of these little dots and pebbles and stuff that are in that are going to be suns and moons and stars, planets, you know, whatever, all kind of neat stuff. So that's what that's going to represent. Okay, it looks like our space is twirling pretty good. Our black hole is sucking up everything in sight. So I'm going to add a galaxy. So here we go. Let's add a little galaxy here. Okay. Now if you can see, I'm going to try to shadow this a little bit for you. I know the sun's going to raise heck with us here. But as you can see here, what's going on is as the galaxy, which is the sand in the bottom of the bowl, is moving around, the gravitational pull, which is the circular motion of space, is pulling everything towards the center, into the black hole. I think I'm going to speed this up just a little bit more here. Turn this on just a touch more. Get a little more action going here. You can see what's happening. Try to get rid of that shadow for you. So this is our galaxy. All the sand there in the bottom, that represents our galaxy. As you can see how it's performing, you know, really nice here. It's actually going around. And in the center is our black hole. The water, of course, again, is representing our space, you know, with the gravitational pull. And what it's doing is it's pulling everything from the outside edge towards the center and then being swallowed up into the black hole. Now, with seeing this, it's my question, and I don't know for sure, but the way this bowl works, the way this actually works in real life, as you can see, it's literally pulling up all the lighter and fine material. As you can see it going around, and it's being pulled up and then it's being sucked through the hole here on the top. Now let's just say, for grins and chuckles, that this is exactly how a black hole works. Who is to say that all the lighter material out in space, whether it be a planet or a star or whatever, isn't being gathered just like this, and all the light stuff, all the whatever you want to call it, waste material in space, is being sucked in. So the only thing left is, you can see some of the bigger stuff is sitting there, okay, not really being moved around too much. It is, but it isn't, okay. And let's say that that is our planets, our big stuff like Jupiter and Earth and Mars and whatever, okay. And it's just being, you know, around and around the galaxy. So what happens later on when all the other stuff is sucked out and gone? You know, will we maintain, or will we be sucked in just like the rest of the stuff? You know, I guess that would depend on how much power this thing has, or how much, you know, how big it is. I mean, there's going to be a whole lot of questions that nobody's going to be able to really answer. But as you can see, but this gives you an idea of exactly how the solar system would work with a black hole, you know, with a galaxy. As you can see, the heavier stuff stays on the outside edge, and the lighter material gets swept across and then pulled up, and the vacuum, of course, you know, the vortex, as you may call it, sucks it down through the black hole. That piece right there would represent maybe one of our planets, maybe Jupiter or something, sitting still out there. See, nothing around it, nothing to bother it, not being moved, because there's not enough force to pull it. Well, there it goes. I guess there's force now, but anyway, you get the idea, you know. I'll add a little bit more here to our galaxy. We can continue to watch this just a little bit. So we'll add another little scoop. This is how our galaxy is made, how it's formed. Let's say this is the Big Bang. There's the galaxy, the Milky Way, and the black hole, of course, is Sagittarius A. That's what they call it. As you can see, this is what it would look like. And as the space and gravitational pull pulls it around, it gets sucked up, and into the black hole we go. And I do apologize for the noise. It's Memorial Day weekend. I hope everybody's having fun. You'll hear a lot of motors and cars going by. Again, I do apologize. I was going to try to do this down in my basement today, but it's so dark down there, I don't have enough lighting, and I was hoping this would work out a little better. So there we have it. And you can see our planets floating around. Everything's orbiting everything. And all the lighter, maybe meteors, meteorites, asteroids, whatever, is being pulled towards the center and being sucked into our black hole. So that's my question for NASA and the rest of these scientists. If anybody's watching this, you know, whatever, would a black hole actually be a cleaner for our galaxy, taking the lighter and trashier material away from us so we have a more open space, or, you know, whatever. Of course, in our galaxy, you have to remember there's more than just our solar system. There are tons and tons of solar systems in there. So maybe it will eat up certain solar systems and leave other ones behind. I don't know. Nobody seems to know. But I just thought this would be a real cool scientific kind of a experiment, you know, whatever, to kind of show you what it looks like and, you know, how it actually works. And I hope it's doing justice. As you can see how things are floating around. The lighter material, of course, is being sucked in. Now I can give this a little bit more power. And it will spin a little faster, so now we got more of a gravitational pull. And as this happens, of course, you can see how it picks up the lighter material, draws it up towards the black hole, and down through the center it goes. Disappear into Never Never Land. Now what happens once it goes through a black hole, nobody seems to know. They say that no light escapes, therefore you can't see them. So, you know, this is what it would look like. Pretty cool visual, don't you think? But what if space is exactly like this? What if this is exactly what's going on out there? I mean, we can't say for sure because we don't know. But this just gives me an idea and gives, you know, hopefully you guys follow what I'm coming up with here. But, you know, if this is the case, you know, now look at this planet all by itself here. Can you see it floating around there? We'll catch it as he zooms by there. See him? He's zooming by pretty quick. You see all these planets just floating around while all the other stuff is being sucked away, and eventually, you know, there'll be just, you know, the bigger planets left, and you know, it's cleaning out our system, so to speak, you know, the waste and whatever. Just a thought. I mean, you know, why not? Anybody's guess is as good as anybody else's. So could this be how our solar system, our universe is working? Pretty cool, eh? I'll add just a little bit more here to our solar system. We'll make another bigger galaxy here. Here's our galaxy. Here's our gravitational pull. And the black hole doing its job. Muncha muncha. Look at that. Look at how that forms. Isn't that something? Almost looks like a real galaxy, don't it? Pretty cool. And there you have it. And all these bigger pebbles that are floating around the outside would be, you know, our bigger planets and whatever. And they're orbiting each other, and they're going around their moons and their suns and whatever. And the rest of the stuff is just being sucked in. So could this be how it's working? Would this make sense? You know? Okay, well, before I bore you, let me flip this back around. There we go. Hello. So yeah, just a thought, just an idea. You know, who knows for sure what the actual truth is, you know, but I just thought I'd throw that out there. I thought it was, you know, pretty cool experiment just to, you know, just to share with you guys. And, you know, I hope you get the idea, you know, where I'm coming from on this. But, you know, we'll flip back over real quick and show you one more time. The water is our space. And of course, the space has the gravitational pull. The stuff you see in the bottom is our galaxy, and of course the black hole is sucking everything into it. So, is this what's happening? You know, does it work the same way? You know, good question. What if? So tons and tons of questions. Really not a whole lot of answers, but you know, I thought it was really cool, you know, to show this. And you know, like I said. So anyway, tonight 6 o'clock I will be live on the radio. So I did post it, shared it a couple times here and there. So that would be 6 o'clock Central. Closer Encounters live on Blogtalk Radio. So would you please, you know, join us, and hopefully, you know, call in 347-989-1008, and you know, give me a shout, talk about this, and you know, see what you think. But yeah, well, I'm here. Why not? I'm going to switch this back over, and I'll throw a little bit more galaxy in our space here. How about that? For those of you who are watching. And let me see here. We'll flip this over. Grab some more galaxy here. Okay, and there's our galaxy. The supernova in the middle, or black hole. The water represents, again, our gravitational pull. And of course the sand is our galaxy. And as you can see, all the lighter stuff being pulled towards the center, and then down into our abyss of the black hole. And all those things that you see floating around the outside and whatever, that would be representation of other planets orbiting around each other, and so on and so forth. And that's what I think. I mean, after watching this, and you know, it just kind of dawned on me that maybe this is exactly how a black hole works out in space. Leaving the heavy stuff behind and cleaning up the you know, the inside stratosphere, atmosphere, whatever you want to call it. You know, I don't know what the real term would be, but you know, getting rid of the junk stuff, so to speak. You know. So maybe, just maybe, that's what's happening. Okay, we'll flip back over here. Alrighty, so I'm going to shut this down, and now, and I appreciate everybody's watching and whatever. But tonight, like I said, 6 o'clock, we'll be live on Blogtalk Radio. And I apologize again for the noise. It is Memorial Day weekend out here, and a lot of traffic on my road. So there you go. So anyway, I hope to hear from you tonight, and thank you all for watching. And as soon as I get this done here, I will repost it, you know, to the other pages and stuff. Congratulations to everybody that's joined the Ancient Alien group. There's over 63,000 members, 64,000 members. Awesome job, awesome post. Keep up the good work, and you know, keep your eyes to the skies, folks. And thank you very much for joining me. And have a blessed day, and we'll catch you tonight, 6 o'clock. Thank you.